Hello folks. Well, let's see, this time I want to talk about the use of globbing in bash. So this is where we're using wildcards on the command line, and bash is trying to figure out all the things that match the wildcard that we're playing with. So we'll experiment with this a little bit. We've run into a couple of examples but haven't dived into it too much in detail. So the idea is we've got some pattern that we want to use to describe a bunch of different files or directories or arguments that we want to play with. So when we invoke a command, we say something like, ls star.sh, where we're talking about, okay, I want to look at all of the files in the current directory that end in .sh. So it's easier for the user to type in the pattern than to type in the names of all of the files that fit the pattern they're looking for. So if I want to talk about all of the .c files or all of the .sh files in the current directory, it's easier for me to specify the pattern than to actually type out all the names. So what will happen if I use one of these wildcards on the command line is bash goes through, tries to expand that, finds everything that matches that pattern, and then passes that to the program that we're trying to invoke. So again, if I say something like ls star.c, it's going to find all of the matching .c files and then pass all of those as arguments to ls. So that's the basic idea. There are a few styles of pattern that we use a lot, a couple of wildcards that we use a lot, and then a couple of others that you can also use that probably won't run into as frequently, but they are handy. So the idea is the asterisk matches a string of any length. So if I just type in something like ls star, that asterisk is going to match the names of every file in the current directory. Or if I say something like star.cpp, that's going to match everything that is followed by .cpp, so all of the .cpp files, for instance, in the current directory. So star can match multiple characters, 0 or more, or the question mark, which can just match any one single character. So if I type in something like ls foo question mark blah, it matches all of the files in the current directory that have foo as the first 3 letters, blah as the last 4, and then one more character in the middle there. So we'll wind up using either of these two. Maybe we should experiment with those two for just a second and make sure that this is reasonably clear. So if I say something like ls star, again, this is going to list everything in the current directory. If I say something like ls a star, it's going to match everything that begins with an A. And if I say something like ls star.sh, it's going to match everything that ends in .sh. I guess that's everything in this case. If we want to go with everything that has, I don't know, the letter N somewhere in it. Oops. How about we actually stick a command in front? How about we actually have a white space between our command? So you can use wildcards to try and describe patterns of files that you're interested in. And again, the question mark matches any single character. So if I was to say something like, how about ls, I don't know, question mark, question mark, question mark. Let's throw in 4. So this should match any name that has 4 characters followed by .sh. So there's 4 files in this current directory that match that pattern. And again, this doesn't have to be ls. This works with any command. So if I wanted to get a count of the number of characters in each of those files, and I could use a different command. But again, anything, the wildcard pattern is just saying find things that match this and pass them as arguments to this program, is essentially what's going on. Okay, let's go back to our notes here. So the star and the question mark are the two that we'll use most often. There are a bunch of others you can use. So if you throw in curly brackets, then you can give kind of a choice of patterns in between them. So if I say ls and then in the curly brackets I give, say, r star dot c comma, f question mark, that's going to match anything that matches either of these two patterns, either the r star dot c or the f question mark. Right, so you can use this if you want to say, I want to match either this pattern or this one. You do have to be a little careful with the white space in that. Bash is picky there. You can use the square brackets to say, I want to match any one of the characters inside. So if I say something like ls and then an open square bracket, xyz, and a closing square bracket, it's going to match any file that has a name that is just one of those single characters. You can specify ranges, right? A dot dot z matches anything in the range A to Z, lowercase. Or 1 dot dot 9 is going to match anything in the range 1 to 9. You can throw the caret in front to indicate that I want anything that doesn't match this set of characters. So if I had a caret and then the xyz, it would match any character that isn't an x, y, or z. Or if I say something like the caret and then the 1 to 9, it's going to say, okay, match anything that isn't one of the digits 1 to 9. So you've got all sorts of different ways you can go through and play with expressing patterns on the command line for files or directory names or arguments to be passed to some program. So again, if I say something like ls r star 0 to 9, 0-9, that should probably be a dot dot there, 0 dot dot 9, and then what have we got here? A dot question mark. Okay, this is going to match any string that begins with an R, has any number of characters, and then a digit, anything in the range 0 to 9, and then a dot, and then a 2-character extension. Right, so you can get fairly fancy in your patterns. It's just whatever's handy for you when you're typing in your commands. Or, you can use these in scripts as well. But yeah, this is a good start on understanding what people are doing when you see them playing with globbing, playing with wildcards on the command line. All right, wanted to make sure everybody had an intro to that, and we'll pick up with more Bash next time around.